Hello everyone and welcome to our channel. Today, we will explore an exciting new paper titled Route LLM, Learning to Route LLMs with Preference Data. Before we dive into this fascinating topic, please take a moment to like this video, share it with your friends, and subscribe to our channel for more in-depth discussions on the latest technological advancements. Your comments are always appreciated, so don't hesitate to share your thoughts and questions below. In the ever-evolving field of artificial intelligence, the ability to effectively route large language models, LLMs, based on user preferences is a game-changer. But what does that mean? And how does it work? Today, we will summarize the concepts presented in the paper Route LLM, Learning to Route LLMs with Preference Data to provide a clear understanding, even if you're new to this subject. Section 1. Understanding large language models. Let's start with the basics. Large language models, or LLMs, are advanced AI systems that understand and generate human-like text. They are trained on vast amounts of data and can perform various language-related tasks, from translation to summarization. These models, such as GPT-3, BERT, and others, have shown remarkable capabilities in generating coherent and contextually relevant text. However, as these models become more sophisticated, one challenge is effectively routing queries to the most suitable model based on user preferences. To put it simply, imagine having multiple experts in different subjects. Some might be great at answering technical questions, while others excel at creative writing. Similarly, different LLMs have their strengths and specializations. The challenge is to ensure that each query is directed to the expert most capable of handling it. Section 2. The challenge of routing LLMs. Routing in this context means directing a specific task or query to the appropriate LLM. Imagine you have multiple LLMs, each with its strengths and specializations. How do you decide which model is best suited for a given query? This is where RouteLLM comes into play. The paper proposes a method to learn routing strategies using preference data, ensuring that the most appropriate model handles user queries. To examine a bit deeper, efficiently routing LLMs requires understanding both the model's capabilities and the nature of the queries. This is not a trivial task. Each LLM might perform differently based on the type of question, the context, and the language used. Thus, a dynamic and intelligent routing mechanism is essential to maximize the effectiveness of these models. Section 3. Learning from preference data. The innovative approach presented in this paper involves leveraging preference data to train a routing model. Preference data consists of feedback indicating which model users prefer for specific queries. By analyzing this data, the routing model learns to predict the best LLM for a given task, optimizing the performance and relevance of the responses. Preference data can be collected in various ways. For instance, users might rate the responses from different LLMs, or implicit feedback might be gathered based on user interactions, such as the time spent reading a response or the frequency of follow-up questions. This data is then used to train a machine learning model that predicts the most suitable LLM for each new query. Section 4. Practical applications and benefits. So why is this important? Effective routing can enhance user experience by providing more accurate and contextually relevant responses. This is particularly beneficial in applications such as customer service, content creation, and any domain where nuanced understanding and precise language generation are critical. Benefits of effective routing. Enhanced user experience. By routing queries to the most suitable LLM, users receive more accurate and relevant responses to their needs. Increased efficiency. Efficient routing ensures that tasks are handled by the best-suited model, reducing the time and resources needed to generate high-quality responses. Improved accuracy. Models specializing in certain queries can provide more precise answers, enhancing the system's overall reliability. Scalability. As more LLMs are developed, an intelligent routing system can easily integrate them, maintaining optimal performance without extensive manual adjustments. Customization. Users can receive responses tailored to their preferences, improving satisfaction and engagement. Resource optimization. By directing queries to the most appropriate models, computational resources are used more effectively, which can reduce costs and energy consumption. Examples of applications. Consider customer service as an example. In a customer support scenario, queries can range from simple troubleshooting to complex technical issues. An intelligent routing system can direct simple queries to a general-purpose LLM while sending more complicated questions to a specialized model trained in technical documentation. This improves response accuracy and ensures that customers receive the most helpful answers quickly. Another example is in content creation. Writers and editors might use LLMs to generate article drafts, headlines, or creative content like poetry. Depending on the task, different models might be better suited. An intelligent routing system ensures that the innovative functions are handled by models that excel in creativity, while models with solid accuracy and factual consistency manage factual or technical writing. Section 5, Technical Overview. Let's dive into some technical details. The Route LLM system uses a combination of supervised learning and reinforcement learning to train the routing model. Supervised learning involves training the model on a labeled dataset, where the preferred LLM for each query is known. Reinforcement learning, on the other hand, allows the model to learn from real-time interactions, continuously improving its routing decisions based on feedback. The model architecture typically includes features representing the query, such as its length, complexity, and keywords. It also incorporates LLM metadata, such as their past performance on similar queries. The routing model's output is a probability distribution over the available LLMs, indicating the likelihood of each model being the best choice for the given query. Section 6. Challenges and future directions. While the Route LLM system presents a promising approach, several challenges must be considered. One major challenge is the availability and quality of preference data. Collecting sufficient and accurate feedback can be difficult, especially in domains where user interactions are sparse or noisy. Additionally, the routing model must be continuously updated to adapt to changes in user preferences and model capabilities. Future research directions might include exploring more sophisticated methods for collecting and leveraging preference data, such as using advanced natural language processing techniques to infer preferences from unstructured feedback. Additionally, researchers might investigate ways to integrate domain-specific knowledge into the routing model, further enhancing its accuracy and relevance. To sum up, RouteLLM learning to route LLMs with preference data presents a novel solution to a complex problem in AI. By understanding and implementing effective routing strategies, we can unlock the full potential of LLMs, making them more valuable and efficient. For those interested in diving deeper into the technical details, the link to the full paper is in the description below. If you found this video insightful, please like, share, and subscribe to our channel. Don't forget to leave your comments and questions below. We love hearing from you. For more information, visit the link in the description to read the paper. Thank you for watching, and we'll see you in the next video.